so if you have trouble hearing me, let me know, but my voice should carry just fine. I'm going to talk about a few things today. I'm going to talk about what I consider open science in government. And I think it's going to consist of a number of different parts. How do we take what we referenced earlier, and I'll explain more, open data? How do we combine that with use of open source software? Then how can we engage with the public to get work done? I'm going to go through what we've done so far and what I think is possible in the future. Just a little bit about me. So I've been, that worked in testing. There we go. I've been the Chief Data Officer for about 4 years now in the city of Chicago. I was appointed in 2011, the city's second Chief Data Officer. I originally came in as the Director of Analytics. I hold a couple of titles. I'm both the Director of Analytics for the city and the Chief Data Officer for the city of Chicago. So I've been with the city since 2011. So I manage a city's data science team, which consists of a number of different parts. Because the way I refer to data science is a combination of a number of different things that relate to data. Now we have data scientists on staff that do predictive analytics, but I also manage the city's databases. So the actual systems that keep the things running. If you call 311, does anybody know what 311 is? Right, the non-emergency line. So if you call that, obviously a call gets recorded into a database, and we would call that, and we would use that data for other information, which I'll get into. Open data, where we make data publicly available to others, where you can download for free. You can go and download crime just from the city of Chicago, every single crime in the city of Chicago, business licenses. You can go see what the current quality, what the current temperature of the beaches are right now. Go onto a website, which I'll point out here in just a moment. Business intelligence and reporting. So how do we take data and make reports out of it? We visualize it, create dashboards that can be used for operational purposes. And then finally, how do we use this data for predictive analytics? So for a long time, the city has had data. We've been collecting data in databases, but now we're trying to not only use it just to count what's happening in Chicago, so do averages, but also to do something more sophisticated. Can we use advanced statistical techniques to predict what's going to happen in the city of Chicago and provide better services? So the open science piece of it, what I'm going to get into to outline what I'll talk about, is how might research, when combined with open data and open source solutions and community engagement, be used to increase the effectiveness of the city. Now, cities are very used to building things that are not only for their purpose. Right? So we build roads. You've gotten here through a road, and you've probably gotten here through perhaps public transportation. But the entire thing is predicated on, we're going to collect tax dollars from multiple different areas. We're going to build something, and we're going to allow others to use that infrastructure to do something that's perhaps more productive. So we just built a road not only for city workers to get to work, but we build roads so others can ship goods across them. Now, in political science and economics, we refer to this as a public good. So we produce something for the use of the public. There's a whole economics of it about why public goods work out. Well, what I'm simply proposing is that data and research also needs to be a public good. So as soon as we start thinking about data and research as a public good, what does that actually look like in operation? I contend what this is going to look like is similar to what you see as open science, or what others refer to as open science. Now I'm going to get into how we're doing that and the way I think this is supposed to pan out. And the city of Chicago is the only one with this sort of research program. We're one of the very few cities that has a rich predictive analytics program as we do. We're the first city with a chief data officer. But so now we're trying to lead the way to what is open science and what does that look like for cities, for governments. So I'm going to start off with open data. In 2011, or 2010, sorry, when Mayor Manuel came into office, he said, we need a robust open data portal. Now, Mayor Manuel was coming from being chief of staff for President Obama. And when he was chief of staff for President Obama, data.gov was launched. And it was a national open data portal. You can go to data.gov and you can download data. Now, just as to get ground basic, how many people have ever seen the city of Chicago's open data portal? Okay, good. Has anybody ever seen the federal open data portal, data.gov? Okay, a little bit, maybe even a little bit more. So data.gov was one of the first big open data portals, and certainly the first one for the United States. When it came to Chicago, quite natural to take this initiative and apply it to the city space. And so we launched data.citychicago.org. And what I'm going to contend is that open data, to go and download data, serves a lot of different purposes. Originally it's around transparency, and originally it's around cost savings, and making data available to others. But what we're going to do is we're going to build on top of it. So this is the data portal behind me. The open data portal now has a little over 600 data sets. I mentioned earlier, you can go download crimes. You can go down and see what the current quality of the beaches are right now. You can go and see what the lab results for E.Coli testing at Chicago beaches is. Business licenses. You can see where speeding tickets were issued across the city of Chicago. Not speeding tickets, automated speeding tickets or red light camera tickets as well. So a whole plethora of different things. Some of it really useful for research, some of it's fantastic for transparency. Now the most popular data set on the data portal is not something that's, I don't think, tremendously interesting from a data science point of view. It's the list, names, and salaries of all City of Chicago employees. That by far is the most popular data set. Now we have data sets, so for instance, the crime data set is about 6 million rows. 6 million rows, about 40 columns. You know, that's very robust. So as a research tool, as an object of research, that's more interesting. But that's something that's useful, is that even if it's big, dynamic, you know, big data, it may not matter. It's the topic matters, and people are very interested in how much the City of Chicago puts in. So we launched this back in 2011, and again, data.citychicago.org. You can go and you can download data. If you're a web programmer, you can use the APIs that are available on the data portal, and you can get assisted download data. You can just download Excel files or JSON files or XML files if you even desire, and work with them. And it's completely free. You don't have to register with the City of Chicago. And we're trying to make it more accessible, so we're adding more dashboards and other information, so not just programmers will find useful, but perhaps your parents would even find some useful. So as we make this more accessible, this serves as a catalyst. This serves as a catalyst for a larger movement. We have now made data publicly available. You can download it. People have done very interesting things with it. Now I'm going to dive into them. But before I dive into that, I'm going to point out that after all this stuff that's been done with the Open Data Portal, it's meant to serve as a catalyst for something greater, which really allows people to come together around data. Because now this enabled the City of Chicago to share data with you. And now it really starts to allow us to think about how we can share that data with you and do something interesting with it. But before I get there, and in 2012, the City of Chicago, Mayor Manuel, wrote an executive order which really initiated the Open Data Portal and put it into the force of law. So in 2010, we began the program, and in 2012, we really launched the Open Data Portal. And then we also launched our tech plan for the City of Chicago. And this is the interesting part. Of the 5 major initiatives that the City of Chicago has, Initiative C, which states that we'll leverage data and new technology to make government more efficient, effective, and open. Right. So again, the Open Data Portal is just going to be a catalyst. So one of the things that we promised ourselves to is that we're going to increase and improve city data. So we'll make this data publicly available, and we're going to improve upon it. We're going to do interesting things with it. So this is embedded into our tech plan, which came out in 2012, right about the same time as the executive order. And then we also have this open data report, which you can go and you can find down new things that we're going to do with our data. So again, this is only meant to serve as a catalyst and a basis. And one way to think about this open data movement, and the way to think about what I'm going to explain here today, is that we're meant to be serving as a platform. So going back to the example I mentioned earlier about roads, we built out roads so people can travel upon so they can do something more interesting. And the way that we've now shaped up our entire strategy is, now let's do something more interesting with data, and government is essentially a platform for you to build upon. So the data in which we provide you allows you to perhaps start a business, to be an entrepreneur, to use that data to make money, this free data to make money. A number of different companies from around the Chicago area incorporate this data and bring it in and use it to leverage to make more money. So for instance, here uses, the company here, formerly of Nokia and Microsoft, uses some of the public spatial data that we have online, brings it in to help improve the maps that they have. So this open data kind of creates this ecosystem where people can come around and talk about data, kind of a community square where folks can come and talk about data and share interesting things. Perhaps it's something that you don't agree with. For instance, about 3 years ago, there was this controversy about how many murders were in the city of Chicago. Right, so we had over 500 murders, but there were some questions of when we hit 500. Some reporters, some journalists had counts that said we hit 500. In fact, we would hit 514. Our numbers were 1 or 2 off. What was very interesting about that is everybody was able to look at the exact same data and disagree on a row-by-row basis. Right? Looking at a particular row and say, well, this is not categorized as homicide. Why was it not categorized as homicide? Was it because they later died from injuries that occurred from there? Were they injured during the course of something else and then later died because they were, in one case, shot, were in a car, and then that car then drove into a tree, and the person died from injuries from that? So it was very interesting because it allowed a very open and earnest dialogue about how the city of Chicago was counting certain things. That's a tremendous conversation to have. Did you categorize? I disagree with how this row is categorized. That's a tremendous conversation to have that you couldn't have even 10 years ago. So what's really helped, and I'm not sure if anybody's ever been to Shot Hackback, which this is the 1-year anniversary. They're now over 4 years old. This is a hackathon, or the hack group that comes together every Tuesday. Every Tuesday, and they have for the last, well, over 4 years. By releasing that open data, you have meetups like this come together and start talking about open data and people doing interesting things with it. I'm going to skip ahead to talk about some of these meetups that have been able to occur. So this is a meetup where there's about 105 people that showed up to this one, where you have groups come together and doing, well, sometimes it's hackathons, but otherwise just trying to work on a project. To work on a project to improve the larger community. And here are some of the projects. This project is Sweep Around Us, sweeparound.us. You can go to this website and you can put in an address and you can find out when your streets are going to be swept. And then you could be provided a text message alert before your streets are swept. The city of Chicago took no part into the creation of this application, but we did provide the data which is built upon. So this improves quality of life. This makes living in the city a little bit easier. But we actually didn't have to do anything. So by providing that information, it allows others to build on top of it. Large lots. You can go, if you live in certain neighborhoods on the south side, you can buy lots, vacant lots for $1. The application process that the city of Chicago originally put out was cumbersome. You had to mail in forms, you had to verify things, and it was a cumbersome process. And a group of hackers came together. This group said, well, let's take data that's already publicly available and do something interesting. They were able to create a simplified application process. So if you go to largelots.org, you can have this process created, be completed digitally, with only mailing in one form as opposed to 4 forms. At the very end, it's a property transaction, so some paper is always going to be involved. So this was and you really can't see it with the background here, but it allows you to look at particular parcels that are online. Again, the city of Chicago did not create this, but released the data so others could build upon it. So this is creating better and better evidence that people can use data to build upon their city and leaning towards open science. Chicago flu shots. During the winter, you can figure out where to get your flu shot. Again, the city of Chicago did not create this website, but it's the best way to find out where to get a flu shot. Chicago Works for You. How many potholes were filled in your neighborhood? And other work that the city of Chicago has done. So go to Chicago Works for You. This is a website created by a nonprofit to demonstrate what work is being done in your area. Somebody created this. We have on the data portal, we have estimates of traffic density. We have GPS sensors on Chicago's buses, and we can tell how fast the buses are. And we can use that data to determine whether or not we think the roads are congested based on how fast buses are. Buses travel along main arterials, and we can look at the differences in speed when a bus is moving slowly compared to its average. That means traffic is probably congested. If the bus is moving just as fast or as faster, and we know the roads are not congested. An interesting individual who was trying to learn INFs and how to do electrical engineering took data from our data portal and created this little red and green light to show whether or not the traffic was dense or not, using, again, data from the data portal. So now this open data can expand into the hardware sphere. And that includes the city of Chicago. So the city of Chicago is partnering up with the University of Chicago around, again, data and then sensors. So we're going to be deploying an array, a project we call Array of Things, which is a nameplate on Internet of Things, and then also having an array of the Internet of Things. So it's not just a toaster that is connecting to the Internet that is doing something interesting. These are a network of what will be 300 sensors across the city of Chicago on many street blocks, about 300 street blocks throughout the city of Chicago, that's going to collect data about environmental aspects. So what is fine particulates in here? What is the temperature on a block-by-block basis? That can vary quite a bit based on the shade and the wind and how the shadow is being casted across the streets. Be able to detect when streets need to be plowed, because we're going to be able to physically see that there's going to be snow on the ground. Using infrared cameras to determine when we need to shovel, because there's ice on the ground that we may not be able to see, but we can detect using infrared cameras. So we're going to deploy these sensors across the city, collecting these various different things. Vibration, how much vibration? As a large truck passes by. Are there areas where this is impact? It's an impact here in certain parts of the night. And vibration can sometimes give an indication of how well a cemented pavement is going to be able to hold up because of that large amount of vibration. So what's going to be interesting is that the entire design of these sensors is also going to be open. The software which runs it is open source code. The hardware, the design of the hardware is also open. The actual design of these sensors, the sensors and the design of the housing is also open. In fact, you can 3D print it. The housing of these are 3D printed shells, which we plug in all the sensors, and we'll be hanging around. In a couple of weeks, we're going to be hanging up our first sensors around the city of Chicago. And we're going to first start in the loop, but we're going to move into other areas. For instance, areas that might be prone to flooding, and we detect flooding earlier, as opposed to waiting for somebody to call us and say, my basement is flooding. That's a little too late. And then we're going to make this data available on the open data portal. So this isn't going to be a scientific project that's going to be out there and there's going to be these sensors there, and it's only for scientists. This is actually going to be available to the entire public. You're going to be able to access this data. This is going to be finely granular, high-frequency data. Every 5 minutes, perhaps even 2 minutes, we're still working on the engineering here, you're going to be able to find out data on every single one of these sensors, on every single one of these nodes. So we're going to have about 200 nodes, about 300 nodes, about 24 sensors for every single node to begin with. And it's going to be updated between 2 and 5 minutes. Right, this is going to be very rich, robust data. Now, if you're a scientist, there's some obvious things you can do with it. If you're a data scientist like yourself, there are going to be obvious things you can do with it. But you're going to be able to even use something like this, perhaps in a 3rd grade or 8th grade science class, to be able to really draw a linkage between literal block that you're standing at and what's happening on that block, and the data that describes what's happening around you. So it's going to be a fantastic, very interesting project that's an open project. And again, it's not so much about what we know we can do with the science right now. It's going to be more interesting what others can think about what to do with this science. So again, we're building on top of this open data. We began by just releasing some data. And now we're doing a project where we have hardware out there collecting more data in an open design that's also going to be generating more data. So again, the open data portal in this initial step is just a way to grab the community and bring them together. Because now it allows us to see data, what's happening around us, and talk about it. And use analytics to try to help improve the city of Chicago. One of the things we started doing as well was we started releasing data as open source as well. So you can actually now edit the city of Chicago's data on GitHub. So we have GitHub repositories that contain some data. Because there's some data that exists out there that you actually might know better than we will. For instance, if somebody installs a new bike rack, you might actually be able to see that
and incorporate that data before the city of Chicago does. So we have released some of our data sets where you can actually make those edits directly to the portal, directly to GitHub. Such as behind me, we're looking at street center lines, where the streets are throughout the city of Chicago. So as those roads are being changed and manipulated, you'll be able to actually make, and you can right now, make edits to that. And some of this data has been incorporated, for instance, into OpenStreetMap. So an alternative to Google Maps is using something called OpenStreetMap. They're able to take all the building footprints throughout the city of Chicago, so where are the buildings at, and be able to import that into a program like OpenStreetMap, vastly improving that open source project. And that data is completely open source. So now you're taking a little bit of City of Chicago data and combining it with the edits from millions of individuals from across the globe who are making this open source map available to the public. Because as you know, Google Maps is not freely available data. You can access their APIs freely, but there's some limitations to that. With OpenStreetMaps, you don't have those same limitations. And it lets users submit bugs. So as people were, and in particular one individual, as they were including these buildings throughout the city of Chicago, he noticed that there was errors in the data. So he was opening up issues, saying there's a problem here. There's a building, one building that's being shown as 4 buildings in your data. Here's a correction. I fixed it for you. And was able to submit that fix back to us, and we were able to take that data into our instances as well. So now this collaboration that we have, where we're going beyond just presenting data, but we're also taking data in and taking corrections, is the next step where we can start to engage with others. So then the city of Chicago started producing open source software, mostly around analytics. And we first started that with by looking at our own internal problems. So what are things that we needed to do? And then we realized that we actually had some good open source software that we're producing. First case in point is a piece of software called R Socrata. Who uses R here? Okay, about half. Python? Even more. Something else? No? Julia? All right. So R Socrata. I mentioned earlier that we have an open data portal that you can go and download data and you can hit an API. Well, the problem is it's a little bit hard in R. There's a couple of packages in R where you can download data from an API, but it's not the most intuitive thing in the world. And we were doing this, so we actually wanted to use our own data from our own data portal, and our data scientists need to use that. So how can we actually make this a little bit better? Well, let's write a package. Right? Let's write a package that does all the heavy lifting on the back end. And all we need to know is the URL that we're trying to download. Because right now, if you did it just natively, you have to have the API endpoint, not just the URL, like the URL that's in the browser. But you have to figure out the API endpoint. And that's a slightly different URL, and you have to pull it down in a particular way. Like, well, we're going to keep doing this, so let's just create a package. So the city of Chicago created this package called R Socrata, which, I'll go to the code here, makes it very, very simple to interact with the data portal from R. So it's on-prem. You can go down, again, it's called R Socrata. And this first bit of code up here, this laser pointer's never this first bit of code says LS Socrata, which literally lists every single data set that's on the data portal. And this was actually a new thing. This wasn't the original intention. The second line of code here, this read.Socrata, was the original intention of the portal. Give me a URL. So this is just a URL. If you go and you find the web page, you can just see this is the URL for all the salaries for city employees in the city of Chicago. So that's fine. And you can download that and you can put that into salary. So behind this, we're doing a bunch of heavy lifting to actually get that data down into R and neatly organize it so you get a data frame that looks decent. You don't need a bunch of other stuff. And then it just really makes it easy to look at the mean salaries for all city employees in the city of Chicago. So now it's 2 lines of code. 2 lines of code, and behind it's about another 100 lines of code that's actually driving this process. Well, we first did this. We released this package that basically had this function in it. And that was basically it. Well, somebody else came along from the University of Washington and goes, I was going to release this whole entire package that really only did one thing. And I saw your package. I said, and it's that I'm going to do a pull request and include into this existing package. And that's LS Socratic. Because there's individuals that I want to go to a data portal, I want to figure out where, what all the data sets were on that data. So you wrote a function and did that and included it to this package. The reason it's called Socratic is Socratic is the vendor we use for our open data portal. There's about 200 cities that use Socratic. And the federal government that has about 200 agencies that use Socratic. So this is actually compatible with all those data portals. So if you go to San Francisco, New York City, if you go to LA, they all use the same piece of software, so it's just a matter of using a different URL. It's compatible with all of those. So this is one of those things where we did something internally. We said, well, this is useful for us, and this might actually be useful for somebody else. And we released it publicly as an open source project. And we've gotten bug fixes, we've had new features included, and others have been able to use it. So I think we've had some 30,000 downloads of this particular package and installs of this particular package. And so that seems like it has a high ROI. And what's been very useful for us is the bug fixes. Because it has allowed us to grow our effective team working on this particular project tremendously. There's an opportunity to collaborate with others. This is another project that we released as an open source project. One of the things about our data portal is we automatically update those. So every single morning about 3 a.m., we update all the times. About every 10 minutes, we update the conditions at the beaches. About once a day, we update all the business lessons, whatever the data set may be. For the most part, it's driven by an automated process. Now, this is pretty technical. It's pretty specific to the city of Chicago. But this process, the way that we built this out to automatically update, to give us email notifications when something breaks, was built out in a piece of software called Meetup, which is an open source ETL, or extract, transform, and load piece of software. We said, well, it's built on an open source piece of software. We've arranged everything to work really well, and it works really well for us. And so we released it as an open source project, so other cities and other governments would have the same challenge and adopt it for themselves. So sometimes our audience isn't large, sometimes our audience, we're talking about a few dozens, maybe a few hundred organizations, but this allows us to collaborate and share ideas more effectively. So now we're getting to the idea, even more so, of efficiency. The earlier examples of programs where I was telling you people building on top of the open data portal was about improving the quality of life. But now we're building out software and we're engaging with open source to get efficiency, to share ideas with other governments, so we don't have to reinvent the wheel 3 or 4 times. We have solutions that are already there. So it leads into analytics. So we've released data open. We've had that available. Software developers primarily, have done interesting things with it. We've started to now release open source software at this point. Now we're about 2012, 2013. Now we're starting to release open source software. But we have this big problem of how do we use analytics and data to improve efficiency of the city of Chicago? Well, let's go through a simple example. Can you tell me from this photo where all the potholes are at? It's a really tough question. The city of Chicago is 235 square miles. 235 square miles. So how can we, at a high altitude, tell what's going on? Now, when you go to an individual street, you can see what's happening on an individual street. But how do we actually tell this on a broad spectrum? And specifically, what if we're only interested in certain areas of the city or certain neighborhoods throughout the city of Chicago, and we only want to look at data there? Well, we have the open data portal. We have data that's available. You can actually go look at all the potholes on the data portal. But we need to do a better job. So we launched OpenGrid. OpenGrid is a piece of software that allows you to see what's happening across the city of Chicago. This project actually born out of NATO. NATO and the G8 were hosting a summit here in the city of Chicago, and that was terrifying for us. How are we going to be able to handle all these individuals, all these high-profile individuals, maintain security, and not go off the rails? The chief of staff, or the mayor at the time, asked, why do I have to go to different departments to always understand what's happening? I have to go to this department to find this data, this department to find this data, another department to find another piece of data. So we created this application that was originally internal, which allows us to see what's happening. In the larger monitor in the back here, we're looking at very particular areas and only showing data for very particular areas drawn on the map. Show me what's happening in this neighborhood. Show me what's drawn within this circle. Or we can create heat maps, of course, of what's happening across the city of Chicago. And it allows us to bring data from everything. Basically, anything has a lines we watch. So this is mapping. It's basic mapping, but it's even easier. And if you go to opengrid.io, you can actually run this application yourself. The application that you see publicly, the application that you can interact with, is using all that data from the open data portal. So you can map and you can see what's happening around you. In fact, you can pull out your phone and say, show me all the Open 311 requests around you. And it uses the location of your phone and maps what's happening around you based on the most recent data available. So this is now making data more usable. So of course we can release raw data and folks like yourselves can do something interesting with it, but we need to reach that next user group. Those who don't know how to download data and really interact with it. So we actually use this as an open source project. So you can go to our GitHub page and you can take a look at OpenGrid yourself and you can improve upon it. Now we use you can interact with OpenGrid, go to OpenGrid.io and interact with it and look at that data. Look and map data. We also use it internally as well. We use it as our internal situational awareness tool. So obviously we have data internally that we can never release publicly, and we use that data internally. So we don't release 911 calls, but we use 911 calls with the same application to see 911 calls happen in real time. Tree emergencies, as a storm, like the storm that came through last night, that's going to damage a lot of trees. Some of those trees are potentially going to damage power lines or damage homes. So the city of Chicago frantically drives around and tries to trim these trees before any damage happens because of that. Well, it's one thing to know where people are saying that, hey, a tree is broke. It's another thing to see where all your cherry pickers are driving around. And so we use this application internally to map where all of our vehicles are at in the city of Chicago, where all these tree emergencies are at, and then we dispatch all of them to these different tree emergencies to make sure that we take care of the problem before your roof becomes damaged. So again, we use this application internally and also publicly. But what makes it very interesting, because it's an open source program, because it's an open source platform, when you improve it, if you fix a bug or you introduce a new feature, you're improving quality of life for the public because they can now use this application, they can use your enhancements to make it better. But it also benefits the city of Chicago because we're using that exact same code base to drive city operations. So we very much intentionally position this software and how we release this open source project. So any potential contributor from it, and you can adopt it if you are in a different government, if you're in an organization where this sort of functionality is useful, you can adopt it, but now you get to benefit. Not everybody gets to benefit from the same contributions. This is important for governments. It's very easy in government. It would be very easy for me to simply release a project open source and say, look what we've done. We have collaborated with the community and then immediately forget about the project and abandon the code and make it useless to so many other folks. But we've intentionally positioned this project where we have a critical piece of internal software that is dependent on being open source. This is going to ensure longevity of an open source project like this. So it's not just simply abandonware at the end of the day. And what's interesting is how we're able to collaborate with others. The piece of software, OpenGrid, depends on this middle piece of software which actually is dealing with gathering data together. That was a separate project. That was a separate project completed by the University of Chicago called Plenaria. Our project, our OpenGrid software, we spent $250,000 on developing that piece of software. And then we were able to connect that with a completely separate piece of open source software called Plenaria, which that team spent $350,000. So together, we're able to take a $250,000 project and get a $600,000 project out of it because we're able to collaborate together in the open source space, in the open sphere. And then you just get the benefit is that we get to work with a huge community that can make contributions to this. So now we've released data openly. We've now started to produce open source software. We've started to produce open source software, which is real-time business intelligence. The next question is, how are we going to use analytics to improve city operations? So this becomes the research side. So one of the problems that we have in the city of Chicago is we have, well, this is not a problem, but we have 15,000 restaurants.
throughout the solution.
But we have 32 inspectors that have to inspect all those locations. So how do we take 32 inspectors and 15,000 restaurants and prioritize where to send them? Right, this is a tough problem, but this is a queuing theory problem at the end of the day. Right, at the end of the day, it's a queuing theory problem. So how do we match up a very few set of inspectors and find them and pair them with restaurants that are most likely to have restaurant violations? Now, about 1 in 6 Americans get food poisoning over the course of the year. And about 300,000 Americans die from food poisoning. So this is both inconvenient in the sense that when you get food poisoning, you might end up in a hospital or have to go to urgent care or potentially even the ER, let alone it's not comfortable to have food poisoning. But even to the point that people will pass away from it, mostly because of dehydration. So the problem is a tough one. Again, 235 square miles, that's the city of Chicago. And across all these different types of businesses, we're simply trying to find the probabilities of which restaurant do we need to find and which one do we need to visit first. So the food inspection team, very experienced manager, she would create lists of where to send all her food inspectors. And she did a pretty good job. But what we would do is we would reorder, therefore this project was about reordering the order of operations and how we do research, and how we do the inspections. But it's a tough problem, because it's a really involved research process. You are literally going in nooks and crannies across a kitchen and trying to find anything that happened that was wrong. This is not a simple drive-by inspection process. And more challengingly, at the time, I didn't have staff to do data science. I was still hiring my data science staff. So to get this project done, we teamed up with Allstate. For Allstate. We teamed up with Allstate, the data science team that day. Now, Allstate would spend about 10% of their time on volunteer projects, work soup kitchens, adopt a highway, a number of things like that. So we reached out to them and said, you know what, that's fine, that's great. But what if your data scientists worked on a project that was for the public good, that was actually a research project that fit within their skill set? And moreover, instead of signing a contract, signing an MOU, a memorandum of understanding, a contract with Allstate saying, we're going to share data with you, and you can use data in this way and that way, and you can only do certain things with it, and then you have to destroy it when you're done. We intentionally, Jesus, sorry. We intentionally released data on the open data portal that would benefit this project. So instead of having to sign a contract with another institution, which would be another 6 to 8 months a year by the time that would be done, to be able to get work done now, we said use everything that's on the open data portal. Use everything on the open data portal. So we did that. So months and months of work went by to get to what you always want to get to at the end of a research project. And I'm happy to go into more detail during Q&A about this. So restaurants with previous critical violations is a really good indicator. If you fucked up in the past, you don't fuck up in the future. 3-day average high temperature. That's actually one. The hotter it is, the more likely you're going to have inspection. CDPH risk level is kind of an internal calculation. It's not as sophisticated as what you might think it is. The location of the restaurant. Nearby garbage and sanitation complaints. So is there a lot of people complaining through 311 that the alleys have garbage in them? The type of facility. Nearby burglaries was a good predictor. Whether or not the establishment has a tobacco or alcohol consumption license. If you have this, you're more behaved, because not many institutions get these things. So it's a little bit of selection bias, because if you get this, you generally were a good restaurant or you're a good proprietor. And also, as soon as you have it, you don't want to lose it, because an alcohol consumption license is very, very, very valuable. It goes from making a lot of money to not making so much money. Length of time since last inspection. So if it's been a while, you slip a little bit. And the length of time the restaurant has been open, and how long we've been inspecting it. The longer you've been open, the better behaved you tend to be. Again, some selection bias in there. You might be open longer because you're a good proprietor, so on and so forth. You know how to do this better. So we did this experiment. We did this double-blind A/B experiment. We took a 2-month period, and we said, go do your work. Go do your work as you would normally do over a 2-month period. And after you do that, but ahead of time, what we're going to do is we're actually going to predict where you should send all your folks. But we're not going to tell you where you send all your folks. You go do your work. We're going to create this secret list of work you should be doing over the next 2 months. And at the end of the 2 months, we're going to compare. We're going to compare the performance. Right? So we created the list early on, kind of sealed it in an envelope, you know, signed it, dated it, so we all kind of knew that we were playing a fair game. Well, so over a 2-month period, we looked at the first half of the work. So over a 2-month period, the first half of the work is the first month, 4 weeks. And the question was, okay, over that 4 weeks, what percentage of the violations did you find? Now you would expect, if you were going in a random order, that the first month you would find 50% of the violations, half the violations. Well, CDPH, the public health, is obviously not doing things in a random order. There's expertise, there's feedback mechanisms. It's a human, right? So it's not completely random. And what we did find is, in the first month, CDPH found 55% of the violations in the first month. So a little bit better than average, right? A little bit better. And so that's probably the human factor, that she's actually a manager for taking in information and making decisions based on what they know. But of course, what a computer or this research can do a bit better is be more precise about where to go. And in the first month, we found 69% of the critical violations. So what we're doing is we're taking the risky restaurants, moving them up front first. Right? So if you have a risky restaurant that's really likely to have a problem, we got you to move up first. So we're going to go visit you first. And we need to visit everywhere. But if you're not as risky, if you're a more well-behaved, so to speak, restaurant, we're going to move you to the end of the list. We still need to check you, but it's going to be a pro forma check, just to make sure that you're doing things okay. And over the course of a year, if you want to think about this over the course of the year, wouldn't you rather us visit a place that has a problem in January as opposed to the entire year of them operating, you showing up to that restaurant unknown number of times when there was these problems, only to be inspected later half of the year? So over the 2-month period, so you got to count this over an 8-week period, that the improvement was an average of 7 days. So we improved the time to find these violations. Remember, it's only a 5-day week, so it's a little bit more than weeks before. So over an 8-week period, we're able to save a week of how long it usually took us to find a critical violation. That actually really annoyed me. Like 7.41 days. I so wanted to round that up to 8. But my staff reminded me that I'm not God. So this is one of my favorite graphs. So the red line here is how CDPH was finding violations over the 2-month period. So over the 2-month period, there is over 1,200 inspections completed. And over a 2-month period, you find a total of 100% of the violations. This wasn't trying to find more violations. This was trying to find violations earlier. So over the 2-month period, you find all your violations. But the question was, who found the violations earlier? So the red line kind of shows the rate at which you find it. So after the first couple hundred violations, public health found 20% of their overall violations. And they continue to find more as the progress goes on. So this is a cumulative line. But what's interesting is the blue line is the way that we would have done and the way that we were recommending using the statistical algorithm approach. And after the first week, we're already ahead. And we never lost momentum. We were always ahead, even through the very end. And when you get to the very end, that very last week, it's hard to tell, but that blue line just flattens out because we have found everything. And so we were just doing only pro forma checks at the end of the week. Meanwhile, the Department of Public Health really didn't find their last violation, that very last violation, until the very last day. Right? So they're working up to the very, very end, still doing work, still finding problems. And after, with a week to go, our algorithm was like, okay, we found everything, it's okay. But remember, every single one of our predictions was predicted here. We weren't updating predictions as the feedback mechanism was happening over the 2 months. We made a one-time prediction beginning of 2 months to dictate what the next 2 months worth of work would have been. This is very hard to see, but perhaps for the best. This is a website that actually shows every single restaurant in the state of Chicago and its predictive probability. We update this every single day. Yes?
Just to clarify, data-driven approach is the one that all those factors is
Yes. Yep.
and status quo is just based off user reputation. That's it.
Status quo is just the manager doing what the manager was doing at that point, which was some reputation, knowing certain places were problematic places, and so you could always go back there and there would always be something wrong. Based off of feeling, based off of, we haven't been there in a while. So a number of different factors. And what's key is none of this is surprising. I forgot to mention this earlier. None of this is surprising. This is saying, go to a not so safe neighborhood that there appears to be garbage in the streets, and the place had had problems before. It's not going to be the best dining experience. That's a no-brainer of a conclusion, right? And none of these variables surprise you. So we're not trying to do a freakonomics. Oh, let's find a really weird variable that predicts everything. What we're really trying to do is capture what we all know kind of exists already, and the food inspection manager recommended most of these variables, and it worked out in the model. But we're able to assign specific weights, because that's essentially what our statistical model is doing. Is, well, you know, nearby burglaries might matter, but does it matter twice as much, 3 times as much, half as much? And because of those specific weights, we're able to just find things more efficient.
Do you also aggregate source view sites like Yelp or Google reviews, keywords like dirty or smelly?
We actually did it, and one of the reasons is at the time, Yelp's terms of services, it was unclear whether or not that was okay under Yelp's terms of services. Because we're a government organization, because we knew this was going to be a public model, we don't want to make that risk. I think the terms of services have changed now where it would be okay, but we haven't done it yet. But I'm going to get to where you could do that if you wanted to. So this is a website that gets updated at about 5 a.m. every single morning that the food inspection manager can take a look at. Look at a particular restaurant, rank order from highest risk to least risk of every single restaurant in the city of Chicago, including new ones that opened up, because we just wrote a number of scripts behind the scenes that does all the work. So this is actually operational. So this wasn't just a research project. This is an actually operational piece of research. And what I said earlier is that this is also an open source project. You can go and you can take a look at the exact code that's written in R, the exact code that's running this prediction model. And because the data is all on the data portal, you can actually rerun our test results. In fact, that was the intent. By doing this very clean A/B experiment, we can clearly show the performance of our model. What that also allows you to do, it allows you to create an alternative model and run it against the same criteria that we ran against. So we're actually able to control an experiment in the city of Chicago. The reason why we controlled such an experiment was not just for us, but it was also knowing that when this is an open project, if somebody says, you know, I think that I can do a better model, well, prove it. You can actually do that. Is there another piece of data? Yelp scores. Like, well, that's one of the first things. Like, well, somebody will probably take a Yelp score and say, does this matter? Is this a good predictor? And so we release that.
So if I'm a restaurant owner, can I not compute when you are going to inspect me?
No, and that's what's intentional as well. So the experimental period is the place where you can determine. So you could calculate your score during the experiment, but that was a couple years ago removed, and the world has changed. But we did not want restaurant owners to know that we might come from one particular day. We debated this quite a bit, actually, but we did not want them to know. So the way that it's structured, you can't do that. There's one variable that we remove that you don't have access to, and it's who the inspector is, which is an important variable. But we, in the code, we actually included that data, but it wasn't identifiable. We grouped similar inspectors in terms of performance, and we did this bit of work so you could replicate our results, not reveal something that we don't want revealed, and not predict what's going to happen today. So we were very, very careful about this entire process. And that in itself, I think, was about a month worth of trying to figure out how to do this. So you can actually do this, and we've had people compare models. This model is a logic model. That's all. It's just a logic model. People said, well, yeah, GBM, that question. They'll come along, they'll do GBM, it didn't work. It was just the performance was the same. The AUC was the same. The confusion matrix looked the same. And we've had a number of folks try to improve upon it. So one part, we're very glad that even our model, which is a very simple model, worked. We're also a bit surprised that more sophisticated models have not yet worked. We're also kind of glad that that simple model is still so far the best model that you use to make this grade. And you can go and you can look at the documentation. So this Chicago.github.io/e-inspection/evaluation explains this project in more details. And in fact, the documentation was a big deal to us. So we have a technical white paper that goes along. It's in the repo, where you can see us explain in detail what was the equation that we used, what was the data we used, what were the different things that we did. But of course, underlying it, we made sure it was reproducible. So we use R's knitters package. So when we say that the performance improved by 25%, what does that mean? You can read the white paper. It says performance improved by 25%. We improved by 7.41 days. Blah, blah, blah. But what does that mean? Well, behind there's actually a markdown document that's doing the calculations in real time, and live. So we write a bit of narrative, and we say, well, it improves by, and then we write the article that actually calculates that. So you can retrace every single step, every single calculation that we did on this project. So you're not just saying, oh, we did 25. I've written numbers that were, in honest, I thought correct. You know, it's a 25% gain, and then 6 months later, I cannot figure out how I calculated that number. Right? And I'm sure we've all done that. So this was a good practice for us, too, in terms of being able to trace back our numbers in the future. Like, okay, we said it did better, but how did we calculate that? Did we remove things? Was there any weird nuance that we had to adjust for? So that gets us to what I said was open science in government. We started by just releasing data, making it available to others. And we started releasing open source projects, code that we made available to others, and started to engage with others. And by taking that foundation, we started doing research projects with others. By using open data, it allowed us to give you data, and then allowed us to communicate using platforms like GitHub. I was like, okay, let's collaborate on this particular project. And then it allows us to release this piece of code, these research projects, to the public, so you can actually make improvements. You can point out flaws. You can make it better. And that's what I think is open science, and that's what I think is potential. Just like us building roads and others doing things with roads to improve society, you can do the same thing with research and data. I had to read the wrong screenshot there. But I want to talk about this project that we just did. This is my last project I'm talking about. Chicago beaches. I mentioned a couple of times now that we have data about beaches on the data flow. You can go see what the temperature is, you can go see what the recent E.Coli levels were. So here's the funny thing. Every single day, the city of Chicago goes out and we test the water at Chicago's beaches. We take this lab result, we do these Petri cultures to tell how much E.Coli there is in the beaches. Fantastic, right? So we can then say, hey, don't go into the beach, there's too much E.Coli, you might get sick. The weird part is that takes 16 hours. So 16 hours between the morning we take the samples is not done quickly enough for us to actually make a decision that day whether or not the beach is okay to swim in. We can tell you the next day, and that's just the nature of the biology. So the EPA, the USGS, developed a statistical model that was going to predict what is the E.Coli levels today. What do we think the E.Coli levels are going to be this morning? We actually go through our lab results still because we take that data to feed until tomorrow. So the public is determine what actually might have been. Problem is that USGS model was not very good. It only correctly predicted elevated E.Coli levels correctly about 5% of the time. Because from a statistical point of view, it was a very rare occurrence to have elevated E.Coli levels. And from a statistical point of view, the safe bet is it's fine, it's fine, it's fine, and you're going to get an R squared of 85, 85%, 0.85, whatever. Right, so that safe bet would get you a great fitting model from most of how we would define a good fitting model. But, of course, when you think about a confusion matrix, the really important thing was a true positive, right? You really want to get that true positive, right? So it wasn't all wrongs were the same. There was a particular wrong that you're trying to avoid. So what was interesting is, somebody pointed this out. I'm like, great, that's a great research project. We have all this data on the open data portal. My team didn't have enough time to work on that particular project. So that video I showed you earlier of the 1-year anniversary of that Shy Half-Night group, the group that gets together to work on civic projects. For 6 months, between 7 and 12 data scientists, week after week, work on a better statistical model. And I told them this. I said, if you develop a better statistical model, The city of Chicago, and demonstrate it, right? This is statistics, so you can demonstrate that it would be better. The city of Chicago and Chicago Park District will use your model to make decisions on a day-to-day basis. Just demonstrate that it's better. And there's a few other criteria and some other things, but mostly just technical. Well, the team, on that very last week, right before the beach was open, had a better statistical model. So this summer, we're going through a formal evaluation process to make sure, and I think all the data points we need, there's a couple of things that we have to double check just from a statistical point of view. The city of Chicago and Chicago Park District is beginning to use this model to make decisions about whether or not it's okay to swim in Chicago's beaches. So this is now gone full blown, where we've released open data, we've made that available, we have open source code, but now we have complete independent groups can do a research project, improve the city of Chicago, improve the quality of life for the 10 million visitors that visit Chicago's beaches this upcoming summer, between 9 and 10 million probably, that are going to come visit, and they're able to do a research project that was able to improve. Because we can leverage open source technologies such as R, which actually this project was done in Python. This is the correct URL. This project was mostly done in Python. Where you can actually use that code. So now you can make a very direct contribution to the city that's around you. So this is very interesting, this path from just releasing data, to going to this point where there's full-blown collaboration between government and the public. So, this is my contact information here, and I'd be happy to open to any questions that you might have. Photos, okay. Any questions? Yes?
What are examples of businesses that have been built on? I mean, they're kind of hard, and that Zillow was basically built on data, right?
Yeah, there is. Yeah, there's a few different ones. And so I think most of what's happening is large corporations are ingesting data as a piece of their operation. So it's not like they didn't have data before they were taking something, they're leveraging it in a number of different ways. But there's a company, like one of my favorite examples is a company called Construction Monitor. So if you go to constructionmonitor.com, and what this company does is they sell sales leads to contractors, especially about LED work, so energy efficient construction materials. What they do is they actually use our data portals. We list all the building permits that the city of Chicago issues on a day-to-day basis. Every single day. And so what they do is they take a look at that information to generate, these are folks who file for a building permit and folks with different types of permits. So they're going to probably need construction materials, and so now I can reach out to them and provide a sales with them. You need construction materials? Here's this one. That you can find. So that's just one example. There's a bit of
Are there like ethical concerns if businesses were to be built on public data that are not like for example, if you were able to predict how many predicted E.Coli or something worse in the water and then make it available for
I don't think that would necessarily be without public interest. What would be interesting is that while one company can do it for a fee, another company might not be able to do it for a fee, or academic research would also be able to do it. In either case, if it was available for a fee or not without a fee, it's easy to fee example. That's more information than we have in yesterday. And so that's going to be information we have. But realistically, the competition is going to be so fierce, I think, in this area is that whatever that insight might be, it might only be short-lived. Somebody else probably won't be able to do the exact same thing.
I like the project on the food inspection because it's something where essentially the data scientists were able to help an actual city department. I wonder how you see in the future about many of the applications were nice, but we're essentially just using the data and it didn't have an interaction with the city.
Yes.
I wonder how you see that the city departments could benefit from this. So I am thinking about police, about schools, how they might be able to benefit from the data.
Same thing. So you're right. So there's certain things that you can just do, which is better displays data. So a lot of the early civic applications are really great. It's just taking data and displaying it in a slightly better way. But I would point to Open Grid, for instance. Open Grid is a project that is used by the CPD quite extensively to see all these events that are happening around them. Very key question. Not just crimes and 911 calls you should be, but what other things may be happening? Is there a vacant building? It's a very important thing for a police officer who might be going up onto the scene. But they don't keep track of vacant buildings. Another department. So by bringing that together allows them to have their own insight. But I think almost any one of those applications can be potentially useful for a city department. Yes.
If you guys are hiring data scientists, what kind of qualifications are you looking for? Someone that can do R, Python, SAS, or
R and Python. So our analytics teams completely get some open source software. So R and Python are predominant languages. And then programming languages and some database or activities and stuff. But primarily we need data scientists that can do analytics, advanced analytics. And so obviously multivariate machine learning, multivariate regression machine learning, and have a deep understanding of that is quite key. But what's always very key about the research projects that we're doing is we operationalize all of it. So it's very much like a client consulting business. We often refer to departments as clients. So we have now about half a dozen research projects that we do that are very similar to food inspections. And every single one of those, we have to understand what those departments do. When they wake up, the manager makes a decision. Why do they make that decision? And what can we do to help improve that decision? But also not cause so much change control that they're not going to want to do what we recommend. So we are really looking for key insights that we can insert at crucial points throughout the operation to improve the operations. And if you know how to conduct statistical studies or statistical experiments, that's helpful too, because you can do a lot.
Yeah. How do you decide what to have your internal data science to work on and what to have outside volunteers or
That's a good question. It's a bit of triage of matching up. Okay, is this something that it's easy to communicate with an outside actor? So like the E.Coli project, that's easy to talk about public with large. The food inspection one, which was a collaboration, that was really before I had full-on staff. Staff was hired throughout that project. But that was one where it was possible for an outside group to talk to the food inspector. The food inspector was a great manager. The lead food inspector was a great manager who communicated really well. There's other managers, frankly, they get very spooked very easily, and so we don't open that up to an outside entity because they'll just get spooked by that. And so we only really let city staff talk with them. But it's a bit of triage. Where's the skill? What do our data scientists, we kind of take a first pass at? Is there a project that you want to work on? If an internal data scientist really wants to work on a project, then we won't open that up to the public. Yes?
I think you can communicate to the departments the value of what you're doing. Get people who are spooked like, oh, you're tracking us, or get them to buy into value of data and our operations.
So it's not hard to prove that value. The hard thing is to prove how it can be valued. If you ever ask a question sometimes to somebody, it's like, hey, how do you think research can help your day-to-day life? They don't know how to answer that question. So it's trying to prove this is just black box. Right? This works, you can combine numbers in a particular way where it's predictable, you can do something useful. But then sometimes a manager might say, oh, can we use predictive analytics on this project? No, it really doesn't work out. And we all know why, right? Because there's those steps in the process like, no, it's not going to work. It's just not the right data, or it's just not fit right. To a manager who's not aware of this, that's just you randomly saying yes or no. Like, okay, it is or it isn't, it doesn't matter. So what was really important was, for instance, the food inspection project. That's a very minimal project. There's a lot of departments that have inspection teams, and they have more work than workers to go do all that work. And so that was a good thing for managers to anchor this. Like, oh, I have a project that might be a lot like that food inspection project you did, but I have elevator inspectors, and we have a bunch of elevators to go to, and they tell you the story. So I usually try to talk to them in analogies of, oh, for instance, we did this other project. Look what we did for this other project, and it's kind of similar to this problem that we have. That has been very helpful. When it's a very brand new project where there's not an analogy to point to, it's harder to communicate about.
To what extent does Chicago share with other cities that have big data initiatives like Boston or San Francisco?
This is a good question. I neglected to mention two things. One is that food inspection project I talked about. What was interesting is Montgomery County, Maryland, is a large county just right outside of Washington, D.C. You may have heard of it. It's part of certainly the D.C. metro area. So Montgomery County, Maryland, right outside of D.C., they actually took a look at the code that we had and said, you know what, that actually might be useful for us too. And within 2 weeks of them starting that process, they actually took our code, and within 2 weeks, they took our code and they actually do the food inspection process in the same way that we do as well. They actually included Yelp scores as well. So they actually took it, modified it, but they took instructions from themselves and turned out to be predictive there. So they took it, added a couple more variables, because it just worked. And they were off running that exact same purpose as well. So yeah, there's a lot of collaboration there. Just recently, when did I do that? In April, I just established a new research center at Harvard Community School. So Harvard Community School now has something called Civic Analytics Network, where I'm the chair of, and Professor Stephen Goldstein is the research faculty on it, where we've established a research center there, which includes 20 cities. That brings us together when we have meetings. So just this past April, I had a meeting with 20 cities where the whole entire, it was a closed door meeting, where the whole entire purpose was, how can we team up to do things more effectively? Some of it was about these sort of research projects. Some of it was more strategic. Some of it was more vendor management to make sure that vendors weren't playing each other off, playing us off each other. To bring that together, we have monthly calls where we'll usually have between 5, 10, sometimes 15 cities jump on the call. So yeah, there's now very tight collaboration between cities and states and Mexico to make sure that we share ideas, because this mechanism allows us to share very rapidly. Yes.
Are you usually pretty open to sharing, or would you like to be fair trade secrets themselves?
Cities?
Cities.
Oh, so open to sharing with other cities, very much so, because we understand those meetings. Now, there's some things that, for instance, I mentioned was a closed door meeting, because we don't want to go outside those closed doors. But within the cities, yes, because we're really not competing with each other. And in fact, the data life of an executive in the city is, a mayor might be pushing me on a particular project. And I have many projects, and he might be pushing me about several projects. And there might be a project around no traffic fatalities or something like that, analytics around traffic fatalities. Well, if San Francisco or New York City has already done excellent research around that, I can reach out, say, can I just look at whatever you did? Mostly just repeat whatever that city did, because it's probably good research. Repeat that sort of analysis and do it here locally. I've saved myself a lot of time. And likewise, another city gets to do that as well. So if I've done something particularly well, for instance, food inspections or the open grid program, they can just take that and knowing that that's my comparative advantage. So the whole entire notion of trade is comparative advantage. I might be better at certain projects or analytics. You can steal that. You might be better at another project. I'll take that. And altogether, it helps us on our daily lives. It really helps us on our daily lives. Or my day can be easier because I'm able to borrow a little bit from another city.
Could you talk a little bit more about the food inspection project with Allstate? What challenges you face, say, when you partner with volunteers from a company? Or how would someone replicate it with other companies if they are interested?
And we've worked with now a number of companies, so we've repeated this model over and over. The thing is, not the hardest, the thing that I'm always most nervous about is, are we going to get commitments to the project? Right? Because it's little skin in the game. You say, oh yeah, I'll do this project. And if you don't do it, what's the downside? Well, obviously reputation and ongoing relationships. But that's always where I'm nervous. That first few days, the first few weeks, is there traction? And the research project itself may not have traction. It just might not be a tractable research question. So I'm always very nervous at that point. And then after that, as soon as there's traction, then I'm feeling okay. But really not having to sign a contract takes away a lot of the pain that we normally go into a research project. Yes?
So what percentage, so both for releasing new open data and for starting a new analytics project, what percentage reach out to departments and ask for things and
That's good. When it comes to open data, I think for the most part we still push mostly on releasing open data, frankly because sometimes we can understand the value or how an academic might be able to better understand it. And a lot of people come to me and say, oh, do you have this and can you release this because I want to do such and such project. And so I think I have a bit better insight. When it comes to research projects, right now it's about 50-50. About half the projects we proposed, about half the projects somebody else proposed. We actually have these workshops that we put on with commissioners from around the city of Chicago, where we whiteboard and we talk about, what are your problems, and trying to figure out the problems that fit well into a research project. And we go through this multi-step. So we have this 12 steps of a research project, which in fact is 10 steps because there's this joke about we can't count. But we have this, and the first kind of 3 steps is, okay, let's figure out a potential research project. You tell me a bunch of problems, and I might tell you, hey, there's a couple things in there that actually might be a good research project. But we only had a 30-minute conversation. That's not long enough. So we need to have another conversation with you and then some of your staff who really know what's going on. And then we start figuring out, okay, what data do you have? How frequently is that data updated? Is it on paper, or is it in a database? And then sometimes we say, you know what, this is not a good research project. I remember one research project where fire hydrants being open, and the department wanted us to predict where fire hydrants would be open across the city during the summers. And we said, okay, that's possible. And there's some real expense to this. The city staff has to go out and close those things up again, and we really don't have a lot of staff to go do that. There's two trucks that drive around and do that across the entire city. And so we had this, we're like, okay, that might be a good research project. Well, then we sat down, and they were explaining about how it works and how basically it boiled down to, well, you have to have a special key, and with a special key, you can open up a fire hydrant. And then we kind of sat down and said, so this research project is going to be trying to predict who has a key. This is not a good research project. We're not going to do this. Because that's, in effect, when you get down to the algorithm, when you get down to the coding of data, what kind of literature you have to kind of understand. Like that's not tractable. We don't think we can do that. So we backed away. We're not going to do that. So it's a little bit hard to calculate that out. Because sometimes we say no. It's just not a great research project.
I came late, so I apologize if you addressed this. What kind of support have you guys gotten from like City Hall, Mayor, those kind of things?
Very good pointing. So by in fact having this position enables us to have these sort of conversations. And that's what an executive is supposed to have. And as long as you're providing value, then it makes life easier to show that these results are actually improving operational efficiency across the city of Chicago.
On the flip side, can you talk about pushback you've gotten from the data given that the trade has reported on like cameras or the street sweepers are sweeping all like the ordinance districts that so some of these like a little more politically touchy subjects.
That's fine. We actually released the red light thing on ticket data after the tribute analysis. More to the point was we didn't think there was a problem. I actually did some very in-depth analytics on it. And it was very clear it was hardware malfunctions. It is very hard to reproduce a spike. It's one thing to say, well, all of a sudden there's a bunch of new red light ticket cameras. But what was always interesting is like, well, how do I get the up and then how do I get the down again? Right? And so it was very clear that for weeks there'd be 0 tickets. And you could always tell the day that they did the maintenance on it. And you'd see the spike. And then it would come back down. I'm like, well, why the spike? Like clearly the thing's broke, right? No tickets being issued. Like a bunch of tickets, no tickets, and then this weird spike. Well, Chicago's red light cameras at the time, I'm not sure if this is the case, so don't go charging through this, but I think our sensitivity is set at 15 miles per hour over. You have to go 15 miles per hour through the intersection to get ticketed. So you have to be going at a clip. The camera's default is 5. And so when you reboot the camera, in essence, it brings it down. So now you get the spike, right? So now you only have to go 5 miles per hour over. So it's not behavioral. It's not like people are like, oh, the camera's not working, and more people are going through. Like that didn't make it wasn't a behavioral. It couldn't have been a behavioral thing. So how do you get it back down? You fix it. So you realize the spike. You say, oh, the camera's misconfigured. You bring it back down to 5, or bring it up to 15 miles an hour, and then your tickets drop again. Not to 0, because the camera's broke at that point. when you bring it back down to its plain meaning. So we released that data showing like, we don't have anything to hide. It's a mechanical issue. We keep saying it's a mechanical issue. Here's all the data to help further fight them. When it comes to anything else, there's always going to be articles written about anything at any given point. To give you an example, probably one of the biggest pain in the asses I had to deal with was a stupid thing. So, around Christmas, stupid stuff starts getting published. Like the most inane thing gets written about. The most inane thing. And we have community areas in the city of Chicago. Community areas were defined by the University of Chicago in 1918, blah, blah, blah. This whole entire story about how we define these 77 community areas. And these were based on professors. Well, then there's neighborhoods. Neighborhoods are separate than community areas. So there is a Boys Town. Boys Town is not a community area. Lakeview is a community area. And within Lakeview, there's this area called Boys Town. And then there's other neighborhoods like Pilsen. Pilsen is not a community area. Pilsen is a neighborhood. The community area is North Lawndale. But within that, there's this area which is very vibrant with many new, fresh immigrants, generation after generation, whatever the most recent wave of immigration goes to that neighborhood. And that defines Pilsen. And it's not North Lawndale. North Lawndale is this bigger thing. So, and sometimes the neighborhoods are equal to the community areas because of just kind of colloquial language. I forget which one it is. I think it's like an area. Which one was it? It was something like, I think it was Pilsen, in fact. And some journalists downloaded a map of all the community areas in Chicago from the Open Data Portal. And he asks us this question. He calls us and goes, so it looks like the city of Chicago has renamed Pilsen North Lawndale. Well, I go, no, that's the community area, and there's a neighborhood, and those neighborhoods are defined as this thing. We didn't quite get that, and then he did this, then he went out to the street, he went to people's homes and goes, how do you feel that the city of Chicago just renamed Pilsen North Lawndale? I spent a day running around talking to press officers, explaining this concept. I'm like, no, community areas are these things that were created, these are things. And that was because of open data. So, it was shooting myself in the own foot to a certain extent, but that is the stuff where I get annoyed, because it's these pointless things. But other than that, it goes to the point, even a simple map showing where community areas, you will get pain in the ass articles written about you. It's just part of life.
All right. Yes. I'm very impressed with the last stuff you've done. If you had like a wish list for things that you could have, what would you like to have as resources for people or that kind of stuff?
So we're very blessed in a lot of different ways, and maybe I'll go back to this point. This needs to be our next step. So analytics does not scale very well. If you want to double your research output, you usually have to double your research. Yes, computing is getting faster and we can store more data, but it's not moving that quickly. We can do more data research now than we can in seconds, obviously. But compared to last year, I can do much more research. Compared to 5 years ago, it's not like the scales have changed that much. So we need to automate more research. And obviously the industry is moving this way. The reason why we chose food inspections and other research projects that are very similar to that is because any inspection process is fundamentally the same research project. You have a binary area, fail or not fail, and then you have a bunch of predictors. And so we've actually been very strategically tackling it to get to what we call a smart data platform, which is, can we organize data, create a central data warehouse store, which we have now done, and then create an application with some middleman who goes, I need to predict a certain process that fails. And here's my inspection. This is what fail means in my inspection process. And then use, ultimately, machine learning to try to choose out all the predictors that predict that outcome. And so now taking an analytics project, which was a year-long project with a number of different researchers in this entire involved process, and try to turn it and compact it into a day, a week, a month, just anything more than a year. And then only through that means are we actually able to scale research across the city of Chicago. Because it would be wrong for me to say that we can really expand it. So we do a lot of research projects in a lot of areas, but we have 33 different departments. Let's say even 33 different departments, they have 10 different problems, right? 300 research projects, 330 different research projects is not feasible, even in the next few years.
So we need to tackle it in an even a smarter way through this kind of smart data platform to get to that next level analytics scale. All right. Is there anything else? Well, thank you very much. Thanks for having me, and I'm very glad that this meetup group started here in Chicago.
Thank you, Tom.
Look online to come to our next one, and make sure that this is all submitted before you leave. Thank you all.
Thank you very much.